Hello, I wanted to give a brief tutorial on free radical halogenation, and in particular I want us to focus on the mechanism and also on this idea of reactivity versus selectivity. The example that I wanted to do now is methyl cyclohexane. So first let's draw the compound. Okay. Next, we have to pick a halogen, and I'm just going to pick bromine here. And remember, bromine is diatomic. Each of these bromines will have 6 lone electrons around it, but I'm only going to draw the 2 that are being shared between the diatomic molecule. For the initiation step, it's really quite simple. You just have to add some light and or heat. What happens is 1 electron will go to each bromine. Please note I'm going to use the single barb arrow to indicate that 1 electron goes to each bromine. So now we're going to be left with 2 bromine radicals, each with 7 electrons. However, I'm only going to show it as having 1 for clarity's sake to make it a little neater. Okay? Now, the next part of this, after initiation, is the elongation reaction. If we look back here at cyclohexane, methyl cyclohexane, how many different types of hydrogens do we have? The answer is 3. We have a methyl group, which will have 3 hydrogens on it. We have these methylene groups. They're 5 carbons, each with 2 hydrogens. And then we have this carbon here, which is a tertiary carbon with a single hydrogen on it. You remember, bromine is more selective than reactive. So for its primary, or its major product, I should say, it's going to want to take the tertiary hydrogen. So I'm going to go ahead and draw that tertiary hydrogen in. I'm going to draw it in as a different color. Now remember, there are other hydrogens around, but it's going to pick this hydrogen because the radical intermediate that is formed is more stable, because I will show you that in just a moment. So we have one of the bromines reacting, and 1 electron will go to form the new bond, which will be hydrobromic acid. The other electron, which I'll put in white, will stay back with the methyl cyclohexane. Sorry about that. Okay. So now we have the methyl cyclohexyl radical, which I'm going to draw it over here. And it doesn't really matter which carbon I put it on. There's the radical. This radical is more stable than if it had been here, one of the CH2, what had been a CH2 group, and definitely more stable than if it had been on originally from that methyl group. The reason being is that a tertiary radical is more stable than a secondary carbon radical, and definitely more stable than a primary carbon radical. Remember, that's because of 2 reasons. One is hyperconjugation and one is induction. Because the more friends that it has, which this carbon you can think of has 1, 2, 3 neighboring carbon friends, so it can help lend electron density. Also, each of these neighboring carbons have hydrogens on them, which can help do hyperconjugation to fill that partially filled p orbital. I'm now going to redraw the cyclohexyl radical to show you what's going to happen next. So let me redraw the cyclohexyl radical from the previous step. So here's our radical. And now what it can do is it can go on and either attack another alkane or even another halogen. So in a different color, I'm going to show how this electron will come and break the Br bond, where one electron will go with the new bromine and the other electron will go to form the bond with cyclohexane, what had been the methyl cyclohexane. So now we're going to be left with our halogenation product, and the chain can go ahead and propagate again because the other inorganic product is this second bromine radical. This bromine radical can go pull off another hydrogen and continue the reaction. Finally, we want to make sure that we name our compound. According to IUPAC standards. So, according to IUPAC standards, remember the functional groups go according to alphabetical order. So we would have one bromo, one methyl cyclohexane. This time it is necessary to put the locants in, the 1 and the 1, since we have more than one functional group here. I hope this has helped you. And it should be noted that this would be the major organic product.